everyone. We are in Chrome Canary, looking at the Devel branch of Telescope, loaded with some data from a Brazilian Jiu-Jitsu website that Sasha has. I guess it's one of his hobbies. So we have DevTools open up to the Timeline tab, and we have selected JS Profile, Paint, and Screenshots. And I'm going to do Command R to reload and record. So here we have the page load. And before that isn't that interesting because this is being hosted locally. So all the network stuff is instant. Here is the first frame. And it looks like, so this is the timeline piece right here. It looks like it's messed up right now because at the end of this frame, we see that they painted this to the screen. So up until this point, like 2 seconds after page load, the screen's going to be blank. And then at the end of this, we're going to see this. And this set immediate is Blaze running. It's mostly JavaScript. And this is like the normal Blaze.rendering your whole index template. You can see all of these start with this Blaze materialized DOM. If you look, and this continues throughout the whole thing through to the end of this frame almost. These are also materialized DOM, materialized DOM. You can look at the bottom of these flame graphs to get a sense of what part of the template they're rendering. So some of these stacks are larger, not because they take longer time, but because garbage collection is taking time, and it just shows up as part of them. But for instance, here we see we're doing post.getLink. Same thing again. Here is building part of the post share template. Here's a template helper called initials text that's in the avatar template. So we're going through this entire page and going through each of these and rendering the post. If you wanted to try to optimize that, I would instead of looking at this whole thing, just at some point later render a single row, a single post, and just analyze that by itself. So after that, this looks like some animation thing. I didn't notice any animation on the page load. I'm not sure what that is. But after this long set immediate that took 2 seconds, we have all of these JS blocks that start with WebSocket on message. So once we get this message, then we off the WebSocket from DDP from the server, we are updating local collections, and that's what most of this is for a while. I think until we get over to towards the end of this frame. This didn't record very far. I'm going to redo the recording. But like these, we're still getting WebSocket messages and still updating a local collection. So we're getting a lot of data over the wire. By the end of this frame, we can see that we have the YouTube or the video images and the comments. If we go to the frame before, we see that we didn't have those images or comments. So I'm guessing some of this data is the data needed to display that. And then over here, we have more data coming in. And then let's re-record this so that we can see what happens after that. So I'm going to cancel it. I'm going to start recording. Load the page again. And then manually finish. If you do Command R, then it automatically stops itself, and sometimes it stops itself too soon. Yeah, so remember we had the one big long frame, and then this frame that was all the WebSocket on messages, and there's more stuff happening after that got cut off. So over here we have this next frame that once all that data has updated, then we have Blaze doing a set immediate and changing stuff. So, oh, okay, never mind. This highlighter thing is this weird thing. Which came back because I was switching windows using that keyboard shortcut. So forget about everything over there. This is another on message. All right, so I guess the main thing here is that I mean this takes a while, but I mean it's a complicated Meteor app, so it's not egregious. You might be able to look at how much time it takes a single post to render, and look at those helpers and how long, whether they're all needed, and how long they take to see whether that can be optimized. And then this thing, so the telescope is already using fast render, so there's some data that's being sent to the client at page load that's being used to render these posts. So if this data that's coming in on this frame on the WebSocket is things that we can include in the initial fast render data load, that would be good. And now let's look at not the first page load, but going between two different pages. So we're going to start recording, and then we're going to go to the About page, and then we'll stop recording. And so here there's not a lot we need to do. We had this big page, and then everything below the header needs to get removed from the DOM, and then the templates need to render that construct this HTML, and then they need to put it in the DOM. And the header stays the same. So as soon as we hit the click, then we are invalidating the old route and setting the new route. I think we have to scroll down to see what's going on at the bottom of this thing. So first of all, this whole stack is 900 milliseconds is how long it takes for us visually to see the change after we do the click the About button on the header. So here we are in the router invalidating the old route. And this stack looks like it is destroying the old view, the index that we were just on. And then this section, let's see, looks like we're starting to build the new page. Here we're doing SEO, meta tags. And here we're constructing the new views. All right, so that's this section was 72 seconds or milliseconds is taking out the old DOM. This is starting to do the new one, I think. And then we have these two other sections, which is computation recompute and tracker.flash. This one is going down to this big thing. So this, you can see this bar takes up that whole space. This is categories menu template calling the menu items helper, and the categories menu is this thing over here. So, and it's the same as it was when it was on the index. So it's not something that we need to be re-rendering. So that would save us half a second if we took that out. And let's see why is it taking so long. We do a mini Mongo find and fetch, and then we were mapping on that array, doing this get children function and doing another for each on a different collection probably. And we do, so this is like a nested loop that happens right here. That goes until the end of this map, and then we do that over again here. So if we want to look at what that looked like, we can click through. Since we're in development mode, it's not minified, so we can see what it actually looks like. So it's this helper inside of the categories menu template, and we do a categories.find.fetch, and then we are mapping onto it and doing get children, which is the one that does the nested loop. So I mean, it's a complicated thing to do because we're getting the counts of each of these categories of posts. So it's reasonable for it to take a long time. I'm not sure why this mapping is being that. This is happening twice. We can see whether it looks like it's happening twice here. Get children, looks like it's only being called there. I'm not sure. Anyway, going back here. Anyway, so I mean, maybe that can be optimized. I don't know, but we shouldn't be doing it when we are changing routes. We should just be doing it on the first page load and then leaving it in the DOM. Anyway, so that was this whole thing. That was this right here. So third sort of section. We probably invalidated some data over there, so now we're getting some reactive updates. So here's a helper item class that it gets being called when Blaze is constructing the new view. More helpers, item route. So it looks like these are menu item, yep, still menu item related helpers, still menu item. I'm not sure what's going on here. It looks like Blaze is building more DOM stuff. And same thing over here. We've got these jQuery parse HTML things. I'm not actually used to seeing this. Maybe that's just maybe this is Blaze creating the HTML for the categories menu that the data got built for over here. So hopefully that would go out too when we take out the categories menu. In which case, then we're taking out, this is 300 milliseconds, and this was 500. So we'd be taking out 800 milliseconds, and we'd be left with just the time it takes to remove the old destroy view, remove the old thing, which is 72 seconds, and the time it takes to render this, which should be very quick. So that is Telescope.